Okay, recording is on. Screen sharing. Okay, so as we did last week, I will present my solution for the homework as well. I created a folder called course 2, the same DevOps course YAML, and the same. I'm running.
Can you zoom a little bit?
Yeah. Is it better?
Yes, yes.
Okay.
Thank you.
I have the host on web server, but actually it's working. Everything that will run in Ansible will be running locally, so this doesn't matter. I just didn't want to change to put a host to localhost because it doesn't make sense. I also added this become true, and I have these rows: Docker, checks, and on checks I'm setting some variables. That depends on those rows. Changes and checks again. You want to see the Ansible running first or Ansible running after I present the code?
You can run Ansible after you present the code.
Okay, so let's take a look at the. Actually, Mac has some issues with the Docker, and I wasn't able to run with Docker, and I switched to Podman. Therefore, I run a Docker Galaxy, and because of the Podman requires some Docker Galaxy installation, I installed this container Podman collection in order for it to give me the Ansible modules for Podman, because by default when you install Ansible, it only comes with the built-in modules, and neither Podman, neither Docker, and a lot of other modules are not part of the built-in. So you might need to install some collection. This can either you run it via Ansible or run Ansible Galaxy install and the collection name, and it will install it. And there I put the image. I will use the Nginx mainline. I'm not using the stable usually because the mainline is the latest build, even if it's not the stable build. But I never had a problem with it. And then I start the container. I run the Nginx mainline image. This is the volume I have mounted. I set the host name of the container as a web server. This requires state is started. I said this recreate true if I run the Ansible multiple times. Every time that I run the Ansible, it will recreate the container. And I publish the port 80 to 8000 locally. I set the restart true if the container fails for some reason to restart it. And restart policy is on failure. Now, you see, I have run this block section, and what this block section does is it applies the same rules for every task that is part of this block section. In this case, you will see it later on. I'm running with connection local and become no. As you saw in the DevOps course, the become by default is set for true. But since I'm running it locally and I'm running it as my own user, I don't want to run it as a root. Therefore, I don't I disable the sudo access. I tell the Ansible to not use sudo to run this task. Okay, what is the next? The next is the checks with variable basic. And now in the checks, I have 3 files. Main file is uh, it says include the role checks, but task from the value task. And as you could see in here, the value of the task is basic. That means that run the import the task from basic.yaml file. And this is the basic.yaml file. I run exactly the same check as I used to run it with URL, but instead of running it against Ansible inventory, I'm running it on localhost. I ask it to return the content, and I added this false true because Ansible was caching this request, and I on the second request where I have changed the index.html, I was wondering why do I get the same bad request all the time, and it was because Ansible was caching this request, and it was giving me the response from the cache instead of giving me the response from actual the web server. Therefore, with force true, I disable the caching for this task. I register the output with check one. The same connection is local, and then I run some debug on the variable check1.content. Then I have these changes. These changes is I'm using line file module, which is used to change lines in a file, and I'm running it against the index.html, and I set in here this is the default message, check message, and this is what I'm going to replace the first one with. So it means that regex, okay, check replace everything that matches this message with the line that is coming from this variable. State is present, and I told also to this line file to create a backup of this file. And again, connection is local, become false. Also in here, I added a 5-second sleep time before I run the second check. And as you can see here, I did not edit that block file, so block line. So I had to add this connection local and become false on each task. If I would have added this under the same block, I wouldn't have to mention this twice. I could have mentioned this only at the end of the block. And then again, there is the second check that is running the basic 2 that will output the check2.content of this request. And it's fairly simple. And now Clear DevOps course 2. And let's see if it's running. Oh yeah, I Podman machine start. I have to start the Podman. Okay, it's installing the Galaxy. It's already installed, therefore it doesn't do anything. It's pulling the Nginx image, which gives a lot of output. Then installs the container, and then it runs a check. I put this verbal so that you see where this check. So basically, what is this line that the debug is showing in here. I have saved the output in here as a check, and the exact field is check.content. So this is what if I would just show in the variable check, I would get exactly the same output as I get in here. But I'm only interested. Oh, wait, I did not. Just to make sure that it's okay. Let's run it again. This time should be a lot faster because Nginx is already there. Okay, so you see hello DevOps Cursants, the first check, then I do some change. I run the changes, and then I added this 5-second sleep time because I have the experience that it doesn't update instantly the file in the container, and after that I did another curl, and I get the updated output in here. Also, as you can see, it has created a backup file for this index. One is this is the first one, the index which was already changed, and this is the backup with the original content. Easy. Any questions? If you don't have questions for the time, I will stop the screen share. And as mentioned last week, in this week, we will talk about Kubernetes in theory of what is Kubernetes, how it works, what are its components. Then I will show you some demo how to start Kubernetes locally. There are multiple options. I'm using only one. And The only homework would be to make sure that starting next session, you have a local Kubernetes on your computer. Okay? Okay, so what is
Good.
Kubernetes? Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It enables organizations to run applications reliably across different environments, such as on-premise, public cloud, and hybrid setups, which mean on-prem and the public cloud combined. Why do we use Kubernetes? Because it manages containerized application at the scale. What this means? It means that if you set up that you need to have 3 containers of web server, for example, it will make sure that you will always have 3 containers of web servers up and running. High availability, exactly what I have explained, ensure application to run without downtime. That also mean that, for example, if you update your application, it will not stop the whole application from running and then start the new version of the application, but it will do a rollout change of each pod. It takes, depending on how you configure it, it takes one of the pods or a bunch of pods and then start a new version of pods, then shut down the old pods. And until it does that, until all the pods are replaced. It runs application consistently across environments. What this means? It means, for example, you have production, staging, and development environment. If you are using the same images with the same configuration, you will have the exactly same outcome on all those environments. And it has a self-healing components which automatically restarts and replaces failed containers. Because we know that application sometimes dies because of bugs or unexpected behaviors from the user side. So if the application dies, what Kubernetes makes sure it will create another pod and will remove the container that has died. And this way it will make sure that it has the required number of working pod and it has a high availability all the time. What are the key Kubernetes components? We have 2 main components. The first one is the control plane component, and the second is the worker components. The control plane components has the API server, which acts as a front end of the Kubernetes control plane. It handles RESTful requests from users, command line tools such as kubectl or I don't know, curl request. It has a etcd database. It's a distributed key value store that served as a Kubernetes database, stores all the cluster data such as configuration details and state information about the Kubernetes and its components. It has a scheduler which determines which node will run a given pod based on the resource availability and scheduling policies. It has a controller manager which runs controllers to monitor the cluster state and make necessary adjustments, ensuring the desired pod replicas are running. Do you have any questions based on this? What do you mean by load balancer? The Kubernetes is a cluster, and because it's a cluster, every component can talk to any other component, no matter where they are running inside the Kubernetes cluster.
I think he means if you have two Nginx servers, if the traffic is round robin, for example. Right?
Yes, it is.
It is, yeah. It has it by default, or it has it embedded. But what does it use for load balancing?
Now we are jumping ahead of our times.
Sorry.
So basically, the Kubernetes networking is based on services, which does these things. Okay, now we have the worker components. The worker components are virtual or physical machines in the cluster that run application workloads. By default, every worker component will have a kubelet, is an agent running on each node that ensures containers are running as defined by the pod specifications. It will run a kube proxy, which maintains network rules on the node, enabling communication between pods and services. And it will have its own container runtime. We have talked last session what are the runtime. It can be a Docker runtime, containerd, xorio, and or whoever other runtimes exist out there. Some concepts about the Kubernetes. The Kubernetes are running pods. Pods, which are the smallest deployable unit in Kubernetes, typically containing one or more containers. The Kubernetes also have services which provide stable endpoint and load balancing for the accessing the pods. And also have namespaces which provide logical partition within the cluster to manage resources and isolate workloads. Any questions about this? Okay, so let's jump into, let's move on to Kubernetes workflow, how it all goes together. Basically, user interaction. The user interacts with the Kubernetes through kubectl or another API client. Okay. The API server processes the request, authenticates and validates the request, and updates the etcd database. And then the scheduler assigns a new pod to appropriate node based on the resource availability. The kubelet manages that are running on the node, pulls the container image and starts the pod. Then the kube proxy ensures the pod can communicate within the cluster with the external services or within the cluster as needed. The controllers continuously monitor and ensure that the cluster state is at the desired configuration. So with this, we are done with the theoretical. Do you have any questions before we jumped into demo? Everything is clear. What talks to what? Okay, then share screen again. As I explained, locally the Kubernetes can be deployed in multiple ways. I know about Minikube and kinds. I also know some other ways, but I never use them. And I use the Minikube. I don't really like it. First of all, I don't like it because it needs a virtualization engine behind it, like VirtualBox or VMware. And I'm not eager to install such thing on my computer. The other thing is that I mostly use is Kind. Now, Kind is a relatively new project and it basically uses Docker or Podman as a backend for the Kubernetes cluster. And Kind as a Kubernetes native option. As you can see, it's configurable via YAML script. Therefore, it's GitOps compliant. And it has a very simple configuration. As you can see, you say kind is a cluster. In Kubernetes, you will see that every object you deploy will have a kind, and you will have an API version. In this case, the API version is this v1 alpha 1. When it will go in a stable mode, will be just v1 without any alpha, beta, or other stuff. And then you say, okay, have one control plane node, and I just added some options in here to extra mapping, and then have three worker nodes. And I didn't want to install the default CNI, so I just added this line. If you add this line, if you don't add this line, then you have a really out of the box running Kubernetes. And installing it can create cluster config, and you just point it to the config find. Okay. Podman machine is stop, and we'll start Docker this time. As you can see, it downloads the images, then it starts preparing the nodes. It will take a bit of time. Usually it's fairly, and it writes configuration, starts control plane. And then once the control plane starts with all its components, it will start creating the nodes directly, the worker nodes. Yeah. Okay, it's up and running. Then we get this to set up the context. And right now, kubectl get nodes minus o wide. And because we don't have, we disable the default CNI, this is a container network interface, the status of the nodes is not ready. Now, I like to use Cilium as a control plane. Let's not jump ahead. And I'm running. So I deployed on my computer the Cilium CLI, and I can install this control plane, this CNI with the Cilium install command. Then we can check for the status. As you can see, it is deploying some stuff. Some of the pods are pending, and slowly we'll get. As you can see here, it was 4 pending containers. Now it is 1 running, 3 pending. Now 2 running, 2 pending. One more pod pending. And now everything is up and running, and kubectl get nodes right. And as you can see, the Kubernetes is already on the ready state. So all the components of all the default components of the Kubernetes are getting deployed in the kube system namespace. And here is how you get the namespaces. By default, there is a default, the default used namespace is the default one. And if you want to get the other objects, like get pods, and you don't want to, you want to see other namespaces than the default one, then you have to provide this -n and the namespace name. And here you will see all the components that are running. into the Kubernetes. Let's add -O white so that we can see what is running where. So as we discussed, it has a Kubernetes API server, which is part of the control plane. Also, it has a etcd database, again, part of the control plane. It has the scheduler, which is part of the control plane, and the controller manager, again, part of the control plane. And it has its own internal DNS servers that are provided by the core DNS. These are in here running on the control plane, but you will see lots of cloud providers. They are actually running it on the worker, running it on a worker node, because the cloud provider don't give you access to the control plane. And you should always have access to the core DNS, because in Kubernetes it happens sometimes that the core DNS, the DNS is not getting refreshed, and you have to have the options to restart it or to debug it, look at its logs. And yeah, basically it. And you can see there is the CNI related pods which are running on each node of the cluster.
I have a quick question. Do you know an empty, fresh Kubernetes cluster? How much all these orchestration services are consuming, memory-wise and memory-wise, let's say, and CPU-wise. CPU-wise, it's only when there are pods, but memory-wise,
They are very small.
very small. Okay.
But also depends on how large will be the Kubernetes cluster. Because a Kubernetes cluster with 100 nodes and lots of pods and something will have significantly higher consumption of the core services, core applications.
And you know at what size? So by default, I assume you start with 3 control plane nodes, right?
Depends. In here, as you can see, we just started with one.
Okay, I understand locally, but I mean, normally you want high availability and you don't want split brain. So then you need to have 3, as I know from distributed services. 3 is like the minimum you can have
Let's say
availability.
that do you want to deploy your own Kubernetes cluster, or do you want to use a cloud provider? The cloud provider will give you 3 by default.
Yeah.
For you, it depends if it's an important Kubernetes cluster and you're just using it for development or playing around with Kubernetes. One control plane is more than enough, because what's running under it or on it, it doesn't matter, right? You can always lose it.
Yeah, I understand.
But if you want a production grade, then yeah, you should have 3, 5, 7 control planes, depending on how important the data is.
I mean, yeah, something like at least, I don't know, sandbox or something like that. That it's a bit more important than what you just put nightly builds.
Yeah, if you want to keep data for long term and other people are using it and checking it and you have customers on it, then have at least 3 control planes.
And this is correct, what I said, that 3 is because, let's say 2 is because you want availability in case one goes down, and you need 3 because you want to fix the split brain problem, because you can only fix the split brain problem with an odd number of nodes.
But that's actually only true for the etcd database.
Yeah, I understand. Yeah, for that, because that is using for example, like Mongo, it has a quorum, and if the master goes down, it picks another one.
The same is with the etcd database, and if you have the ability, you can even put the etcd database outside the Kubernetes cluster and then just configure it so that it will read the database from wherever it is.
I understand, but the same, you'll end up with this. So if you want availability, you need minimum 2 nodes. If you want to fix the split brain, you need minimum 3.
Yes, you need an odd number of nodes.
Yeah, and that's it. So you start from 2 because you need availability, and then the next odd number is 3. So that's it. Okay, thank you.
So there's a question in here. If you're using cloud services like AWS Azure, does it have out-of-the-box instances with Kubernetes or dedicated services with Kubernetes? Yes, you will have a Kubernetes, everything out of the box. And do we have control plane on the resources used by the workers, like assigning RAM? No, on the cloud environments, you have no access to the control plane. That is the way they make sure that we are not, because they are offering a managed environment, they have to make sure that the cluster is always up and running. And therefore, they have to limit us from screwing with with the cluster and probably damage something that they cannot fix. So they just cut the access to the control plane for the users. We will have full access to the worker nodes, but no access to the control plane whatsoever. Other questions? Okay, so as I said, no homeworks for next week. The ones that did not provide homework this week, they can provide it by next week, the same thing, and make sure you have a way of running Kubernetes locally on your computers starting next week. Okay. Okay. Perfect. Next session will be again next Friday, same time. I will post my kind config on the GitHub repository so that you can use it as an example. And there is also a blog post on my blog about how to deploy Kubernetes in Docker, if you want to look at that. Thank you very much. I will stop the recording and